So when we're solving using substitution, remember one of the equations was written in general form and one was written in gradient intercept form. And the reason why substitution is the best method to solve these is because we can simply just substitute one into the other. It's really easy just to substitute one into the other. If we look at this, both of these equations are in general form. If I wanted to do substitution here, I'd first have to rearrange one of them. So then I might get the x all by itself or the y all by itself and then substitute it into the other. I can do that, but it's a bit of work and there's a quicker and easier method to do it. So what we can actually do is we can look at vertically adding the equations. So what does that mean? All right, here's one equation in general form, here's another. Now I'm going to call this 1 and I'm going to call this 2. Now we're going to add 1 and 2 together. I'm going to add those two equations. So we're going to do a vertical addition where we add all the x terms, we add all the y terms, and we add all the constants. So what's 2x plus minus 2x? 0. What's 3y plus 5y? All right, so I'm going to have 0 with the x's plus 8y is equal to, what's 7 plus 1? 8. Now, so really I'm just left with 8y is equal to 8. So therefore, if I divide both sides by 8, I'm going to get y is equal to 1. Then I can substitute y is equal to 1 into either one of the equations to work out what x is going to be. Okay, so I could substitute y is equal to 1 into here, and that would be 2x plus 3 is equal to 7, then rearrange to get x all by itself. So sub y is equal to 1 into 2, so then we've got 2x plus 3 by 1, which is 3, is equal to 7. 2x is equal to 4, x is equal to 2. That was a lot easier than having to rearrange one of these equations and then substitute it in. Now, let's look at this second one. So if I add those two equations, what's going to happen to the y terms? They're going to cancel out. So then we're only left with one unknown, being the x's this time. We can solve for x. Then once we've solved for x, we can work out our y. Now, it's all well and good when we have two equations that the y terms, when we add them, they cancel to 0, or the x terms, when we add them, they come to 0. That's fantastic, but sometimes they're not given to us so nicely. Sometimes we have to do a little bit of work first. So let's have a look. With question 2, if I add equation 1 and add equation 2, what's going to happen to those y terms? They're going to cancel out. So let's just do one more for argument's sake. So add 1 and 2. So what are we going to have with our x's? 5x. Then what's minus 2y plus 2y? 0. And then what's 9 plus 16? 25. So x is equal to 5. Then sub x is equal to 5 into, doesn't really matter, 1 or 2. Someone call out which one they want me to sub it into. 1 was said first. So it's going to be 3 by 5 minus 2y is equal to 9. Then if I subtract 15 from both sides, minus 2y is going to be equal to 9 minus 15, which is negative 6. And then y is equal to 3. Alright, so far so good. If I added each of these equations, what would happen to the x terms? They're going to cancel out. So I'm not going to do that one because you can do that in your own time in a second. What's going to happen in C? They'll cancel out again. Now, look at these. So, given that the equation, give the equation that results when both sides of the equation are multiplied by 3. So, if we multiply both sides of this equation by 3, we'd have to multiply all the terms by 3. So it'd be 9x plus 12y is equal to 6. Agreed? If I multiply both sides by 3, I have to multiply all the terms by 3. So this would be 9x plus 12y is equal to 6. Can I multiply all of these terms by 2? What would I get if I multiply all of this by 2? Both sides of the equation by 2. Minus 4x minus 10y is equal to 6. I've multiplied all of the terms by 2. What if I was to multiply both sides of the equation by minus 5? I have to multiply all of the terms by minus 5. So this is going to be minus 20x plus 10y is equal to minus 55. Now, you might be saying, all right, all well and good. What has that got to do with solving by elimination? Well, look at this. If I try and add these two equations like we were doing in those previous examples, are my x's going to cancel? Are my y's going to cancel? No. What if I was to multiply one of the equations so then that could be the case? Who could see, how could I multiply one of these equations to become more useful? Alright, let's do that. Let's multiply one by 3. So this is going to become 9x plus 3y is equal to 27. And I'll call that equation 3. So now add 3 and 2. So if I add equation 3 and equation 2, let's start off with the x terms. What's 2x plus 9x? 11x. What's minus 3y plus 3y? 0. And that's going to be equal to, what's minus 5 plus 27? 22. Therefore, x is equal to 2. And then I can substitute that into any of these equations that I want to. And it will give me the correct solution. So sub x is equal to 2 into 1. So this will be 3 by 2 plus y is equal to 9. So 6 plus y will be equal to 9. Y will be equal to 3. Because 9 minus 6 is 3.